Assalamualaikum to our lecturer, Dr. Amani Firuzah binti Muhammad Kamil. Our project title is Small Increment Estimating Value Application. That is thermal expansion of railway. Okay, I will introduce our group member. Firstly, my name is Muhammad Nabi Farhan bin Muhammad Nasir. Second, Tekmo Dani Santoso bin Sumar. And third, Nur Amirah binti Hashim. Fourth, Umar Arif Rizwan bin Umar Razi. And then Nur Amiza binti Muhammad Yazid. And lastly, Muhammad Shazwan bin Muhammad Ramli.
Hello, my name is Umar Rizwan. So today I will explain about a theory. So in this project we have two theory. There is a small increment and an estimating value. Okay, for the small increment, given that a dependent variable y and independent variable x are related by means of this formula, that is y equal to fx. Suppose that x is subject to a small increment. There is a delta x. In the present context, we use the term increment to mean that delta x is positive when x is increased, but negative when x is decreased. The exact value of the corresponding increment delta y in y is given by this formula. That is delta y equal to fx plus delta x minus fx. However, since delta x is small, we may recall from the definition of derivative that from this formula, there is fx plus delta x minus fx divided by delta x equal to dy dx. We can simplify this formula into delta y divided by delta x equal to dy dx, and we can conclude this formula into delta y equal to delta y equal dy dx times delta x. So for the diagrammatic approach to this approximation for the increment in y, let us consider the graph of y against x is in the neighborhood of the 2 point. P for the coordinate P is x, y, and for the coordinate Q is x plus delta x and y plus delta y. On the curve whose equation is y equal to fx. So in the figure, PR equal to delta x, QR equal to delta y, and the gradient of the line PS is given by the value of the dy dx at P. So with in the figure, we're taking SR as an approximation to QR. We obtain from this formula SR per PR equal to dy dx, and we simplify this formula into SR per delta x equal to dy dx, and we can conclude that delta y equal to dy dx times delta x. Okay, for the estimating value, estimation or estimating is the process of finding an estimate or approximation, which is a value that is usable for some purpose, even if the input data may be incomplete, uncertain, or unstable. Estimation involved by using the value of statistic derived from a sample to estimate the value of a corresponding population parameter. The sample provide information that can be projected through various formal or informal process to determine a range most likely to describe the missing information. An estimate that turned out to be incorrect will be overestimate if the estimate exceeded the actual result, and an underestimate if the estimate fell short of the actual result. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Triad Modendi Santoso bin Sumar. Card metric number is CF190200. I will now explain about thermal expansion. Thermal expansion is the tendency of matter to change its shape, area, volume, and density in response to a change in temperature. This is because when the substance is heated, the molecule will gain kinetic energy and begin to vibrate and move vigorously, usually creating more distance between themselves. This will cause the substance to increase in size and volume. The increase in volume depends on the material are made of, as the coefficient of thermal expansion is varies. The higher the coefficient, the more it will expand in reaction to being heated. Our project focused on the railway expansion. The expansion and contraction of railway is due to seasonal heating and the friction from the train, as it will expand when receive heat and contract when it release heat. To design the railway, we need to make sure there is a small gap between every joint of the railways, just like picture number 1. That is a joint of the railway. This is due to let the railway expand when heat is absorbed. If not leave a gap, this will cause the railway to buckle, known as sunking, just like picture number 2. So it is important to leave a gap between joint and when design and constructing the railway.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Amira binti Hashim. Okay, today I would like to explain a bit about the calculation. So as we know, the engineer want to build the railway track in cylindrical track, but due to the different temperature, railway tracks need to be built with a gap between the rails to provide space for the metal to expand when weather change to hot weather. Okay, to get the equation of the volume of the cylinder, we use the triple integration method. So we need to find the volume of cylinder, that's why we use triple integration method. But first we need to determine the interval of R, Z and also theta. For the interval theta, we use 0 to 2 pi because it's complete one rotation. And for the interval R, we use 0 to R where R is the radius. And for the interval Z, we use 0 to h, with h is the height of the cylinder. And then we start the integration of R. Then we get RZ, we substitute h and 0 into Z, then we get RH minus 0. And then we start integrate RH, then we get R square h over 2. And we substitute the R and 0 into R, then we get R square h over 2 minus 0. And lastly, we integrate the theta, and then we get R square h over 2 theta. We substitute 2 theta and 0 into theta, then we get R square h in bracket 2 pi over 2 minus 0. Then we get the integration of volume is R square h pi, and we rearrange it, then we get volume pi R square h. So this is the volume of the cylinder where we use the triple integration method.
So after the derivation of the formula of cylindrical shape volume by using the double integral method, we get that the formula is V equals to pi R squared H. The rod starts to expand when the temperature reaches 40 degrees Celsius, and when the temperature reaches 70 degrees Celsius, the expansion of the rod is maximum. The coefficient expansion of steel is 1.152 times 10 to the power of negative 5 per degree Celsius, and the length of the rod that we use is 20 meters, while the radius of the rod is 40 millimeters. So the elongation is 1 millimeter, which is the minimum gap left when the expansion of the rod is maximum, plus the difference of the temperature, which is 70 minus 40, times with the coefficient expansion of steel. So we get that the elongation approximately is 8 millimeter. So the length of the rod before the expansion is 20,000 millimeter, and after the expansion is 20,008 millimeter. To get the length of radius after the expansion, we consider the distance of the gauge. This is the distance of the gauge, and the range of normal gauge distance is from 1,420 mm to 1,460 mm. And mostly, the construction of a railway track use the distance of 1,435 mm. So 1,435 mm is minus with the minimum gauge distance, which is 1,420 mm, we get 15 mm. So the radius after the rod expansion is 15 plus 40, which is 55 mm. So the point RH moved from 40 and 20,000 to 55 and 20,008 mm.
Now we need to calculate the approximate change. Approximate change in V, for example dV. We use the total differential dV equation, which is dV equal to dV over dr multiplied by dr plus dV over dH multiplied by dH. Okay, for the previous calculation, we get the volume of cylinder, which is pi r square h. So we need to differentiate r and h. When we differentiate dv over dr, we get 2r pi h, and while we differentiate dv over dh, we get pi r square. Okay, now we calculate the difference of r, where 55 is the radius after expansion minus 40, which is a radius before expansion, and then we get 15. And for the difference of h, equal to 20,008, where is the height before expansion minus 20,000 height after expansion, we get 8. Okay, so we total difference of v, then we get dz equal to 7.544 multiplied by 10 power of 7. For the exact change in v, we use this equation and we substitute 50, 2008, 40 and 20,000 into the equation, and after we calculate it, we get the final answer, which is 8.930 multiplied by 10 power of 7 millimeter. If we compare between the approximate change and exact change, there is no slightly difference, as these two answers is almost the same. We calculate the approximate change and exact change to know how much the railway track can expand during hot weather. We know that the expansion joint gaps are the gaps which are deliberately left between the rails to allow it for the expansion of the rails when weather change to hot weather. And from our calculation is based on the standard specification of railway track design. So the design of the road is suitable to be used in the construction of railway tracks.
Warahmatullahi wabarakatuh. My name is Muhammad Shazwan bin Muhammad Ramli. My matrix number is CF190222. Today I want to explain about the result of our project. Okay, research found that 20% of rail accidents are caused by the broken track and happen due to the track expansion. Engineers found that expansion joint gap should be 7.5 mm to 8 mm, and it will be at the risk if gaps are beyond this range. So at the higher level of temperature, bucking will happen because the tracks are fully connected by welding. For this project, we want to know the increasement of volume on the road when the track expands and estimate the volume of the expansion. We use the formula that we get is V equal to pi r square h. For the elongation, 1 mm gap is a need when the expansion is the maximum. So we multiply that length of the road with the coefficient expansion of the steel and the temperature and plus with 1 mm gap for the maximum expansion. Minimum distance is 15 mm and plus with the radius of the road, which is 40 mm to get 55 mm. The radius of road after expansion. As I mentioned, we found that the point RH moved from 40 to 2000, and then 50 to 2008. As for the estimated change, we get a dz equal to 7.544 times 107, and for the extent change is in volume, we get a dv equal to 8.960 times 107 mm 107 m meter. The design we calculate of the road suitable to use in the construction of railway tracks.
Okay, for our conclusion, in this project, we approximate and calculate the change in volume of road that is used to build the railway tracks. We use the application of partial derivative, which is small increment and estimating value, to solve this problem. The road used to build railway tracks is in cylindrical shape. So, double integral, we can derive the formula for volume of cylinder. After we get the formula of the volume, the calculation is proceed to find the change of radius and length of the road. The result shows that there are 5 mm difference in the change of radius, while the different length in length is 8 mm. The exact change and the approximate change in the volume is also shown in the result, where they are slightly different between the two. From this project, we get to know the application of partial derivative in a real life. We also learn that to maintain the condition of the railway tracks and avoid bending is to make sure that the gap between the railway tracks is 1 mm even after the maximum expansion of the road. Also, to keep the 1 mm gap, the length of the road need to be in a range which is 1420 mm to 1460 mm. As in this project, we follow the standard specification of railway tracks design. So the design that we suppose can be used to construct the railway tracks. And thank you.